Assalamu alaikum everyone, myself Anika Imran, registration number 21TE54. This is our DSP lab number 6, and in this lab what we have to do, we have to represent the discrete time digital signals into the frequency domain by using FFT, that is fast Fourier transform. This is our task number 1, and in this task what we have to do, first of all we have to take a signal and then we have to show its even and odd components by using FFT. First of all, we have taken our signal and the components in the signal are from 1 to 8. Then we have taken m factor, and the value of that m factor is 2. Whenever we have to take FFT, we have to take the even odd function separately, and then we have to take its fast Fourier transform. So now what we have done, we have taken the even and odd component. Okay, first of all we have taken the even component and odd component, then we have taken its length. Here we have taken n is equals to length of x. It is the length of this function. Okay, then we have declared its zeros, and then we have used a formula in which we have a limit that is from 1 to n. This is our formula, and after that what we have used, we have displayed our original signal, then we have determined signal, and then we have a reconstructed signal. Now if we run our function, this is our output. First of all we have our original signal, then we have our determined signal, that is 1357. So this is our lab task number 2, and this lab task is same as the lab task number 1, but in the first one we have taken the n samples by ourselves, but in this one the samples are given to us. So what we did, we have taken a sample that is 0204, and again we have taken m, that is a factor, and the value of this factor is 2. Then as we are doing in fast Fourier transform, so we have decomposed our signal into the even component and the odd component separately. Then we have taken the length of both even and odd functions, and after that we have used zeros. And again, now here what we did, we have used a condition. This is our condition, and according to this condition, if this condition is met, then we have our fast Fourier transform, otherwise we have no results. And then we have used the formula, and again we have displayed the original signal and determined signal. And when we run this function, we have this following output, in which we have our original signal, this, and this is our determined signal. This is our lab task number 3, and in this lab what we have to do, now we have to compare the given signal with the standard function. And in this lab we have basically two signals, that is the x signal and the y signal. Now what we have to do, we have taken our factor of m, and its value is same as the previous one, that is 2. And as we have two signals, so now what we have to do, we have to take the even and odd functions for both of them separately. This is the even function of x, this is the odd function of x, this is even for y, this is odd for y. And now we have taken the length for both even and odd functions of x and y signals separately. This is length of x, and this is the length of this is the length of y, and in between this we have taken the FFT functions of x and FFT function of y for even and odd separately. And then we have declared the length of these functions, we have taken the zeros, and we have used the formula for x and y signals separately. And after that we have displayed our original signal of x, decimated signal of x, and the original signal of y and decimated signal of y, and at the end we have compared both of the signals, the DFT or the decimated signal of both of the signal, that is x and y. So when we run our function, the output is this. This is our basic output, in which we have the original signal of x and decimated signal, and the original signal y and decimated signal of y, and after that we have DFT of x and the decimated signal of x. And this is our last lab task, and in this one what we have to do, we have to compare our signals to the basic standard functions. So here we have our 4 signals that are given to us, that is w, x, y, and z. These are the four signals that are given, and after that what we have done, we have taken our fast Fourier transform of all the signals separately, and we have used a standard function of the MATLAB, that is myFFT. After that we have used FWSTD. Here STD stands for the standard function, and its FFT is given to us. So as we have to compare the results of the standard FFT, so that we have given the basic titles and we have displayed our signals by using DISP function. Okay, now what we have to do, when we run our function, the basic output is this. We have our functions that are given to us, and at the end we have compared our signals.